I want to do some more examples on solving exponentials that are a little bit more challenging. So I'm going to just do a few different styles so that you have some guidance on how you can solve these on your own. So here on this first example, I want you to notice that this one's a little bit different than some of the others we've seen because that exponential piece is not already by itself. If you look at the last couple of examples that we've had, you do have that exponential piece is by itself. So if you find that you have an equation where you have just one exponential and there's a lot of other stuff going on, you really want to try to clean that up first. So I'm going to start by adding that 3 to both sides. So I have 40e to the 0.6x equals 240. And then I'm going to divide both sides by 40. I have e to the 0.6x is equal to 6. So again, that's a nice little tip. If you see just one exponential piece there, and again, there's a lot of other stuff going on, clean it up first. Try to isolate that exponential part. Now we get down to this part here, and I'm looking at it, and I really don't know what to do next, right? I don't have the same base. There's no way I can get a 6 to be e. So I'm going to use that second strategy here. I'm going to take the natural log of both sides. I do like natural log here because it does match the base. So when you take the natural log of base e, it basically cancels that part out. Technically, it's a factor of 1, but it's going to cancel that part out. And it's going to allow us to bring that power just out front. So we end up with 0.6x equals the natural log of 6. Now I can finish solving, divide both sides by 0.6. And I get an answer of x equals natural log of 6 over 0.6. Now, it's perfectly fine to use parentheses or to not use parentheses. I tend to like parentheses more often. I don't know why I did that. I just find it easier to read, but usually your text will leave out the parentheses. So this means the same thing, natural log of 6. So this is the final answer, but if you use your calculator, and I encourage you to try this at home, you should get about 2.9. All right, let's try another example. Here I have two exponentials, right? I have an exponent on the left and on the right. There's nothing really else I can do, right? I don't have any extra plus or minuses except for in the exponent. So I would first try to see, is there a way for me to get the same base? Here I have it 4, which is really just a 2 times 2. Here I have a 5. I can't see of any way to make these the same base. So I'm going to go ahead and use that strategy of taking the log of both sides. My bases are 5 and 4, so I'm going to stick with the natural log. That tends to be the most common way to do this, but you could use the common log as well. Get the same answer. So I'm going to take the natural log of 5 to the x minus 2, and then the natural log of 4 to the 2x plus 3. Now remember, you have that power rule, so I can take that power out front. And the same thing over here. Remember that when you bring that power out front, it is being multiplied. Because it's more complicated, I do want to leave it in parentheses to show that that whole thing is being multiplied there. And same thing on this side. Now, what I'm going to do is I need to keep solving for x. I want to get x by itself. I'm a little bit stuck right now, so I'm going to have to clean this up. And I'm going to start by distributing and multiplying through. I know it's a little weird to think about multiplying with natural log of 5, but it's just a number. So x times natural log of 5 is just x natural log of 5 minus 2 times the natural log of 5. Here I have 2x times the natural log of 4 plus 3 times the natural log of 4. Now I'm solving for x, so I do want to get my x's together and get everything else on the other side. Again, I know it looks kind of weird here, but I can see I have an x here and an x here. So I do want to bring this to the same side of the equation and bring everything else without an x to the other side. So I'm going to subtract this one from both sides. And then I'm going to add the 2 natural log of 5 to both sides. So I'm just trying to separate it out. so that things that have an x are on the left and things that don't have an x are on the right. Now, this is a little trick that I'm going to show you, and we've actually seen it before, but it doesn't come up too often. I'm trying to solve for x here. I really can't put them together because I have this natural log of 4 and 5, and they're messy numbers, and like, how do I combine those together? It doesn't really make much sense, right? So what you can do is you want to use a factoring strategy here. So I'm going to factor that x out of both pieces. So if I factor the x out, then I have natural log of 5 left minus 2 natural log of 4. And I'm actually now able to solve. All I want to do is get that x by itself. So I can divide both sides by natural log of 5 minus 2 natural log of 4. And I have x is equal to 3 natural log of 4 plus 2 natural log of 5 all over natural log of 5 minus 2 natural log of 4. And actually, we would really leave our answer just like this. So I know we have our log rules where you could, take that addition idea and multiply and put those back together, take subtraction and make it division. But typically when we're solving an equation, we don't do all that at the end. We just leave our answer like this. So this is the final form. If you want to use your calculator, you could figure that out as well. You want to be really careful just typing everything in on your calculator. Show you that screen a little bit better. So you may want to do it in parts. So here's my numerator. So I would do 3 natural log of 4 plus 2 natural log of 5. So that gives me about, let's see, 7.377758908. In the denominator, I have natural log of 5 minus 2 natural log of 4. Negative 1.1631508.1. And then if I divide these, so 7.377758908 divided by negative 1.1631508.1, I get about negative 6.34. So I can get my approximation that way. We're just going to be really careful with your calculator, making sure that you are not combining your logs by accident, right? So I have distinct logs here. I have my numerator, I have my denominator. I'm using as many decimal places as I can because I don't want to have a rounding error. So that is our final answer for that one. Now this last one, again, is another kind of toughie. So I'm giving you some 3 examples that are a little bit harder than the ones that we saw in the last part. Here, hopefully this is jumping out at you, or maybe not, that it kind of almost looks like a quadratic, right? I kind of see the square here, and I see an EX here. So, if I just rewrite it to myself here for a second, it kind of almost looks like it's in that quadratic form, right? Where you have that first part being squared, and then you have that second part, and then your number at the end. So this is a great example to use substitution. So let's let u equal that e to the x factor, right? So this is, remember when you use substitution, this would be your u, and this becomes your u squared. So it becomes u squared minus 4u plus 3 equals 0. Think about how we solve a quadratic. You could try factoring. You could use the quadratic formula here. Factoring does work, so I'm going to go with that one. And this is the correct factorization to make it come out to be accurate. So I'm going to set each piece equal to 0. So I have u minus 1 equals 0, u minus 3 equals 0, and then I have u equals 1 and u equals 3. Now, just remember with substitution, you're not done, right? Because it wasn't u, it was actually e to the x equals 1, and then e to the x equals 3. So I have to do a little bit more work. I do have to solve these 2 little equations now, and I can do that by taking the natural log of both sides. Now remember, because you have the same base and the same base here for the exponent, you basically get that canceling. It becomes a factor of 1. So that x is going to come out front. And I have x equals natural log of 1. And then here, same idea. The x is going to come out front, and then the natural log of e is just 1. So x equals natural log of 3. So here we have our 2 answers. One last thing I want to note is we can also figure out what the natural log of 1 is. So it's a rule that we've already talked about, but in case you forget, you can use your calculator here too. So just typing that in, natural log of 1 is 0. So the answer here is actually x equals 0 and x equals natural log of 3. Now, natural log of 3 is just a, excuse me, a decimal value. So I can leave it as natural log is 3, or I can round it to about, let's say, 1.099 here if I want a decimal approximation. But do check at the end, see if there's anything else that you can do to simplify. Remember, whenever you have a log and that value is 1, you're going to have a 0 because it's the 0 exponent that gives that 1 value.